All right, so let's go ahead and go through this real quick. And then we can move on to our notes and stuff for today. So for today, first I want to go over the assignment from Friday, which we already went over a couple of these in class. So let me pull out my answer sheet and see the two that we already did. All right, so we already did, no, not that one. I think it was 1 and 4 in this class period, correct? Yes. So on number 1, again, all we had to do was write a ratio. So for number 1, we had 54 out of 583 times at bat. So 54 home runs out of 583. Again, for that one, you're just writing a ratio. So that's pretty straightforward. On number 2, this one, again, same thing, just writing a ratio. There are 182 girls in the sophomore class of 305 students. What's the ratio of girls to total students? So it's 182 to a total of 305. You don't have to simplify or anything else. That's it. That can be your final answer. Now, yes, there are other ways you can write a ratio. You can write it in words using the word to. You could use a colon, but all I'm asking you to do is do it as a fraction and leave it like that. For almost everything we do in this class with the ratios, we're going to end up using fractions in order to solve. So you might as well just get used to writing them as fractions. Number 3, same thing. It gives us the length of a rectangle, gives us the width. It wants to know the ratio of length to width. So that is 8 to 5. And that's it. Now, on number 4, the ratio of the sides of a triangle is 8 to 15 to 17. Its perimeter is 480 inches. Now, we did this one in class on Friday. I think there's about 5 of you that I gave a worksheet to. So let me just run through it real fast. Since we had the perimeter, now you could draw the figure first if you wanted to, but these are going to represent the sides, and you're going to have 8x, 15x, and 17x. So 8x, 52, that 480. We added them up, we got 40. And then you divided by 40, and you got x was equal to 12. And then you just had to go back through and multiply to each of the parts of the ratio. So instead of 8x, now it's 8 times 12. Instead of 15x, it's now 15 times 12. Instead of 17x, it's now 17 times 12. So the values for number 4 were 96, 180, and 204, all in inches. So then on number 5, now this one we hadn't done yet, the ratio of the measures of 3 angles. Now it is very similar to the example we did on Friday. So we have 3 angles in a triangle. Again, like I said, you could draw an image if you want to. Say that's my triangle. Well, one's going to be 7x, one's going to be 9x, and one's going to be 20x. So I take that ratio and change it into values being multiplied by some variable. In this case, I use x. All 3 of those, since they're angles, have to add up to what? 180. So I do 180 equals 20x plus 9x plus 7x. Add them all up and you get 36. How do you get x by itself? Divide. When we divide by 36, x is 5. Again, that's not our final answer because they want the measure of each angle, right? So we have to plug it back in. So we have the 20x. We have, oops, instead of 20x though, we're now going to say 20 times 5. We're going to say 9 times 5. And we're going to say 7 times 5. So 20 times 5 is 100. 9 times 5, that's going to give us 45. 7 times 5, that's 35. If you wanted to double check those answers, those added together is 180. If we really want to be specific, these measures are in degrees. So we can say 100 degrees, 45 degrees, and 35 degrees. So that was the first half of the homework from Friday. The second half was all about solving proportions. And again, we already did a couple of these. I believe we did number 1, which our number 1 after we cross multiplied and solved was 56. And we already did number 3, which went once we cross multiplied and solved was 8. So let's take a look at the remaining problems that we hadn't done yet. On number 2, again, how to cross multiply and solve. 3 times 24 equals 8 times y. 3 times 24 is 72. divide off the 8, and we get 9. And that's our answer. On number 4, again, cross multiply and solve. 3 times y is 3y. 9 times 18.2. That one you probably have to use a calculator for. Maybe I'm not, but I don't know that one off the top of my head. 9 times 18.2 is 163.8. And finally, divide 3 off from both sides to get y by itself. And you get 54.6. All right, now we come to number 5. Number 5, you are going to have to distribute once you solve. Now, there's not really enough room to do it right there, so I'm going to do it down here. So here's going to be number 5. So number 5, we're cross multiplying. So I got 4 times 2x plus 3 is equal to 8 times 5. Distribute the 4 to both parts. 4 times 2 is 8x. 4 times 3 is 12. 8 times 5, 40. Bring the 12 over by subtracting it. Again, we want to get x by itself, so now we're solving. 40 minus 12 is going to give us 28. And finally, get x by itself by dividing off that 8. And x is 3.5. And that's our answer for number 5, 3.5. For number 6, again, we have to cross multiply, and again, we are going to have to distribute. So 4 times x plus 1 and 3 times x minus 1. Again, distribute both those. So the 4 goes to both of those. The 3 goes to both of those. 4x plus 4, 3x minus 3. Combine like terms, get the same terms to the same side. So first, get rid of that 3x, bring it over to the left. We now have just x plus 4 equals -3. And we can bring the 4 over by subtracting. So x equals -7. All right. For number 7, if 3 DVDs cost $44.85, find the cost of 1 DVD. Well, you could do this a couple ways, but again, since we're doing proportions, I'm going to set up a proportion. We have 3 DVDs equals $44.85. Set the proportion. What's 1 DVD going to cost? Well, 1 over an unknown value. Again, you don't have to do it this way, but for the idea of what we're doing here, we're going to set it up as a proportion. Cross multiply and solve. So 3x equals 4485. Divide by 3. And you get 14.95. Now, again, if you just went and divide by 3 right away, that's fine. I would have expected you to do all that extra work, but since the idea here was setting up proportions, I wanted to solve it that way. On 8, again, you have to set up your own proportion. So it says we're measuring plants in a field. The first 25 plants measured, 15 of them are under a foot in height. So I'm going to set up a fraction. 15 out of 25. So this is 15 plants are less than a foot tall out of 25. And then it says that the total number of plants in the field are 4,000. So equals total number of plants in the field would go on bottom because 25 was the total number of plants. So 4,000 is also the total number of plants. On top of what we're trying to find, the number that are under a foot, which is what the number 15 represent. Whenever we set a proportion, we have to make sure that they have something in common on both the top and bottom. So here the tops represent the number of plants under a foot. The bottom represents the total number of plants in the sample size. Cross multiply. Now there are different ways you could set this up, but however you set it up, once you get to the part with cross multiplying, you should get the same values. So if you get 25x and 15 times 4,000, when you cross multiplied, your proportion was good. All right, but there's 4 different proportions that you could write that would give you that same outcome. So now 15 times 4,000, that's 60,000. And then finally divide by 25. And x for the plants that are underfoot are going to be 2,000 400. All right. So that was the homework from Friday. Now we are going to go into notes. So for today, we are going to be talking about similar polygons, or similar figures. Anytime we talk about similar figures, we're talking about figures that are the same shape, but a different size. So we talked about this with dilations. Now we're going to be talking about a lot of geometry shapes. We're not going to be using the coordinate plane as much, but still same idea. We have two shapes that are similar because they're the same shape, different size. When we have similar polygons, or if two figures are similar, then all the corresponding angles will be congruent. And that's why I have two different figures here, but I've marked all the angles as congruent. And all the corresponding sides will be proportional. So take a minute, first copy that part down, and then I'm going to add something to this. All right, while you guys are copying down that first part, the scene chart that I passed around. Anybody that didn't get the chance to write their seat number on the scene chart or on roster, I should say. On today's schedule, I moved it. Here it is. This is fourth period, right? We get done at 10:54. Yes. This one is, yeah. Okay, so I said I was going to add something to this. So on here, we have two figures. Now, does everybody remember our symbol for congruency? So if I was to say that angle, or let's say the triangles are congruent for a second, I'd use this symbol, right? It looks like this with an equal sign underneath it, right? That's our symbol for congruency. Well, now we have a different symbol for similar, but it's essentially just the same squiggly line that we have on top, just no equal sign. So on here, if I want to say these two figures are similar, I can say that triangle BAT is similar to triangle DOG. So these two triangles are similar. This is the way that we would write that statement. Now, once we know that we have similar figures, we can say that any of the corresponding angles are congruent, which they're already labeled on this one. So I can say that angle B is congruent with angle D. Angle A is congruent with angle O. And angle T is congruent with angle G. Now, notice these are congruent, right? Oops. I did not mean to drag my pen there. Fix that. All right. So on here, the angles I wrote as congruent. The figure I wrote is similar. We will never say that the angles are similar. We won't use that symbol of similarity, that squiggle by itself, unless we're talking about the entire figure. So when we have similar figures, the angles are congruent. Now the sides are proportional. So what we're actually going to set up for that one, instead of setting up a statement like these, is we're going to set up a statement where we have ratios that are equal. And we're actually going to set up so that we have all three of our ratios equal, because we have three different sides here. So we have, from the first triangle, BAT, we have the sides BA. So I'm going to write that on top. Then we have AT. I'm going to write that on top of the second one. And we have TB. I'm going to write that on top of the third one there. I'm going to match them up with the corresponding parts of the bigger triangle there. So BA matches up with DO. AT matches up with OG. TB matches up with GD. So if I was to have any one of these sides compared with the sides that are corresponding, they would be proportional or equal to the ratio of any other set of corresponding sides. And we gave that a name in the last chapter, right? Or in the first chapter that we did. When we were talking about a dilation, we said that they shared a common scale factor. Same thing here. This ratio between these figures is called a scale factor. So it'll be the same between each part. Now, there is one other thing that we need to talk about with our scale factor. Is everybody good on this page before I change it? I see people copying, so I'll wait for a minute. All right, let me go ahead and go on. Okay, so the other thing that we need to mention here, scale factor. So again, we talked a little bit about it. Scale factor is the ratio between similar figures. The scale factor will be the same for all corresponding sides and length of all corresponding parts. So again, any length measure that we have here, whether it's sides or any other piece, we will end up with the same scale factor. If we look at these two figures here, the scale factor of triangle CAT to triangle BIR is 2 to 1. Yeah, we read that. Now, if you look at any of those parts, it shares that same scale factor. So every single measurement that's in CAT is twice as big as that in BIR, including, if you look at the height that I have drawn in from AS and the height that's drawn in this one for ID, they also share that same ratio. I also wrote off to the side the perimeter. If we add together all the outside pieces of that big triangle and all the outside pieces of that little triangle, the ratio of the perimeters is also the same. So here we had 14.2, here we have 7.1. So really any single dimensional measurement will share that same scale factor. So no matter what parts they have drawn in, if the figures are similar, the scale factor will be the same for any of those corresponding parts. Okay, I know I finished a little bit earlier in this class period, but in my other classes, I did not assign an assignment yet for this. I'm gonna wait until tomorrow and give you time in class for this one. So I'm gonna do the same for you guys. So we're gonna stop here. So once you got this set of notes copied, that's gonna be it for today. Tomorrow, there will be an assignment that I'll give you during class time, all right?